Okay, example 8. A professor conducted an experiment to find the relationship between time and memory. The professor determined the model m equals t sub 0 minus 15 log of t plus 1.1 gives the memory score m after t months with an initial score of t sub 0. After how many years will the student with an initial memory score of 94 have a memory score of 65? All right, so this is just how memory works. You learn something, right? And if you get tested the day you learn it, let's call that your memory score, okay? And then a month passes, you haven't looked at it for a month, and then you take a test on it again, you're going to forget some of it, right? So your memory score will decrease. That's kind of what's happening here, what they're doing. This is not an official formula, it's just what was written in the book. There are 3 particular variables here, and if you look, it says m, we have t sub 0, and we have t. And be careful when they start using subscriptive variables, t sub 0 and t are different things. All right, and it tells us the memory score is m, and it says after t months, so t is how many months have passed since the experiment began, and the initial score is t sub 0. Okay, so they give us this formula, they give us 3 variables of the formula, and they describe what the variables represent. Again, this is a very typical algebra problem. Here's an equation, here's all these variables, here's what all the variables mean. And then they go on to tell us some stuff about these things. It tells us the initial memory score of 94, so they're telling us initial memory score of 94, and that means that t sub 0 equals 94. And we want to have the memory score after t months to be 65. So m equals 65. I've got a formula that says after about how many years will the students. Now, you'll see very clearly it says after t months. So know that when we get the answer, it's going to be in months. We'll have to convert the months to years, right? We can do that after we get the answer. So if the answer comes out to 12 months, it's a year, right? 24 months, 2 years, 36 months, 3 years. So again, if we can figure out the month's answer, then we just convert that answer to years. So it does say years. I'm not concerned until I get the answer in months. So if I fill in what I know and leave a variable what I don't know, I'm going to get 65 equals 94 minus 15 log of t plus 1.1. You'll notice it's a logarithmic equation. There is no base written on the logarithm, right? So what logarithm base is it? Yeah. Base 10. And again, I'm just going to substitute what I know into the problem, then I'm going to look at that problem and say, how am I supposed to solve that problem? This goes back into what we saw yesterday. I've got a logarithmic equation. There's numbers attached to things. I either get log equals log or log equals number, one or the other. Well, since I have a log expression, I got numerical expressions, I'm going log equals number in my brain. So, first off, I'm going to move the 94 to the left, which gets me negative 29 equals negative 15 log of t plus 1.1 base 10. Now, I don't want that negative 15 in front of the logarithm. There's 2 options here. Option 1, I can make this the power of that. We'll call that the bad option. If log equals a number is your goal, it's much easier to divide by a number than to make it a power. So again, if it was going to be a log equals log scenario, obviously I'm going to put that 15 in there as a power. But if it's log equals number scenario, I can just divide by that number to get rid of it, getting it over here. So notice 2 negatives make a positive, so I get 29 over 15 is equal to log of t plus 1.1 base 10. All right. Now 29/15 happens to not divide evenly. It comes out as a decimal if you do. 1.9167 or 9333, I'm not sure what it is. 1.933333. So I don't want to put 1.933333. So I start rounding things instead of using a fraction, I'm going to get less accuracy. So I'm going to keep it as 29/15. So when I rewrite this now, what we saw yesterday when we had log of something, base something, equals something, rewrite it as an exponential. So 10 to this power equals that argument. So it's going to be 10 to the 29/15 equals t plus 1.1. At this point, now I do need to get a decimal. So I'm going to get that. So I'm going to go 10 caret parentheses 29/15 end parentheses equals. If I do 10 caret 1.93, that's about the same as 29/13, right? Or 29/15. Notice it's off by a bit. 85.76, 85.11. So again, it's important that if you keep it in fractional form instead of decimal form, you're going to get more accuracy. So 10 to the 29/15 is 85.76958986. So I'm going to go, let's go 85.77. Okay. So again, 10 to the 29/15 equals 85.77. I just evaluated it. And if t plus 1.1 equals that, to figure out what t equals, I'm going to subtract 1.1, right? So minus 1.1 comes over here. Using good decimal subtraction technique, we're going to put the decimal points lined up. 7 minus nothing is 7. 7 minus 1 is 6. 5 minus 1 is 4. 84.67 equals t. That's months, right? So after 84.67 months, this particular person should have a memory score around 65. Okay, the question says how many years. There's 12 months in a year, so we take the number of years, 84.67 divided by 12, and we get 7.05, so about 7 years. I'd like to use the word about because it's not exactly 7, but it's pretty close to 7, right? My guess is if they did it right at 7 years, maybe it's 65, maybe it's 66, whatever. It's right around that general area, right? And that's kind of what this professor figured out. So, general idea of all these word problems you're going to get in your homework. They're going to give you an equation. You need to substitute what you know into the equation and find the one thing that's missing using one of the techniques we've learned in this chapter for solving exponential or logarithmic equations.